Welcome back for more metric conversion and dosages. Today we're going to be talking about household and metric systems. Other names for the household system include English, British, or Imperial system. You may have already noticed that I am most comfortable or familiar with calling this the English system, but I will try to be consistent with your textbook and refer to it as the household system. Let's start with some household equivalents or conversion facts. 1 quart equals 2 pints. Notice that the abbreviation for the units is there beside the unit itself. 1 pint equals 2 cups. These are not teacups or coffee cups. They are a specific measure. They are a measuring cup. And 1 cup equals 8 ounces. 1 ounce equals 2 tablespoons. 1 tablespoon equals 3 teaspoons. All of those units here are used to measure liquid volume, the volume of liquids in the English system or the British system or the household system if you prefer. In the household system, we also have units of weight, where 1 pound equals 16 ounces, and we measure length with measurements such as 1 foot equals 12 inches. To say 3 feet equal 1 yard and 5,280 feet equal 1 mile, but let's leave our chart at this for the moment, noting that this indicates the weight line. Here are measurements of length in this line. You will find this list of household equivalents on the pages 99 through 101, a little bit at a time. Please consult your syllabus also, because all of these plus some more are in the list of required equivalents that you should either have previously memorized or you should be memorizing now. So I'm going to move this list of equivalents out of the way. We can determine how many cups of cola are in a 20-ounce bottle of cola. All right, what do we know? That's where we start. We know we have a 20-ounce bottle of cola. I'm going to put that 20 ounces over 1 because it doesn't change the amount of cola I have. And now I'm going to recall a conversion factor. I know that 1 cup as a measuring cup for liquid volume equals 8 ounces. So 1 cup equals 8 ounces. I'm going to put the ounces in the denominator so it will cancel. And then I'm going to put the 1 cup in the numerator. Where can I cancel? I can cancel the ounces. So I'll have the correct unit of cups because that's what I'm looking for. And now I can multiply straight across, or I can go ahead and say, there has to be a common factor here between 8 and 20. They're even. In fact, there is a factor of 4. So 8 divided by 4 is 2. 20 divided by 4 is 5. So if we multiply straight across now, we get 5 cups over 2 with no units. So we have 5 halves cups, or 2 1/2 cup, converting this fraction to a mixed number. Here is example 2. Okay, an order is for 2.5 ounces of liquid supplement every 4 hours. How many teaspoons will be administered for each dose? The first thing I'm going to do is to take this 2.5 ounces and rewrite that as a decimal, so 2.5 ounces, OZ, over 1. That's where we're starting. Okay, how many teaspoons is this? Well, we need to think about our equivalents. Do we have a teaspoon to ounce equivalent? No, we don't. Not in the list I gave you. But we do have this equivalent. We have 1 ounce equals 3 tablespoons. And then we also know that 1 tablespoon equals 3 teaspoons. Put a little tail on my T there so it doesn't look like an addition sign. Let's see, have we canceled everything we need to? Our ounces canceled, our tablespoons canceled, leaving us with our teaspoons, which is what we want. Now we can multiply straight across. Looking across the bottom real quick, it's all ones. So there will be nothing on the bottom. Well, it's not nothing. It would be 1, but we don't have to write the 1 on the bottom. 2.5 times 3 times 3, 9 times 2.5, that will be 22.5 0.5 teaspoons. That's quite a bit. Something that we're going to be talking about throughout this course is, now that you know that 2.5 ounces of liquid equals 22.5 teaspoons of the same liquid, which way should you be measuring it? Should you be trying to measure out 22.5 teaspoons into another container? Or should you be pouring 2.5 ounces of liquid into a measuring cup that has ounces on its side? The second option makes more sense, and you'll be less likely to make a mistake. We're going to be doing an entire activity on that concept later in the course, but think about it as you go through these. Let's look at one more example from the household system. This is an application course. So although you may be able to work through something mathematically and get a mathematically correct answer, you must be able to translate that to the real world. Here's a good example of that. Okay, so you have an infant who weighs 104 ounces. That's where we're starting. How much does the child weigh in pounds and ounces? Ooh, and ounces. That's a little different. But we know we're going to be converting to pounds, right? So we can use the conversion factor. 16 ounces equals 1 pound. And once again, I often write that symbol in cursive, so you don't mistake my L for a 1. All right, and if we just do this division with a calculator, or if we say, well, let's see, we can cancel some things, right? Actually, 16 can be divided by 8 to get 2, so we can cancel an 8 out of each of these, and 8 goes into 104 13 times. Took me a moment to figure that one out, but there we have it. And so now if we multiply straight across, oh wait, I need to cancel my units of ounces. Now if we multiply straight across, we get 13 pounds over 2, which would give us 6.5 pounds, except I didn't ask for the weight just in pounds. I asked for it pounds and ounces. So we have 6 pounds, that's good, but we need some ounces weight. So at this point, you can take 1/2 pound and once again multiply it by the conversion factor, except this time it's inverted, right? So pounds cancel, 2 goes in there once, 2 goes in there 8 times, and we get 8 ounces. We get 6 pounds and 8 ounces is equivalent to an infant weight of 104 ounces. So now it's time to talk about the metric system. Since I've already mentioned that the metric system is a base 10 system, just like our numbering system is, it should not surprise you to see this little device that I'd drawn before. All right, but we're going to put slightly different things in here. In fact, in this place right here where we are going to start, I am going to start with the unit. Well, one is a unit of something. Now the unit will vary, that's why I'm using unit here. If you're talking about a unit of length in the metric system, it would be a meter. If you are talking about mass, the unit is a gram. And if you are talking about volume, the unit will be the liter. But since this little device is there just for the mnemonic purpose of helping you remember the prefixes you should use, we're just going to leave it as unit right now. And if you have 10 of those units, that will be equal to a deca unit, whatever that unit is. If you're measuring meters, it would be a decameter. Again, that's because you had 10. So if you multiply that unit times 10, you get a deca unit, whatever that is. Gram, liter, meter. Okay, another 10. If you have 10 decagrams, perhaps, then you would have a hectogram. If you had 10 hectograms, you would have a kilogram, a kilo. Kilo meaning, let's see, 10, 100, 1,000. Kilo meaning 1,000, hecto meaning 100, deca meaning 10. Let me go ahead and write the symbols for the various metric units that we'll use. Okay, so that's meters, liters, and grams there. But you can keep going the other way if you split. Okay, we can move the other way from units as we did before by doing division. If you split a unit, like a meter, into 10 smaller units, you will get a decimeter. And if you split say a decigram into 10 pieces or 10 masses, you're going to get a centigram. We divide by 10 again, our next prefix, writing a little big there, our next prefix will be a milli, because we are 10, 100, 1,000 times smaller than our unit now. Now, here comes the tricky part. We kind of skip these two. We don't even fill them in, all right? Or we don't provide a prefix. There are prefixes, they're just not commonly used. So what we're going to do next over here is we have a micro whatever. Micrometer, microliter, microgram, and this is another 1,000 times because we went 1, 2, 3. If you divide a millimeter by 1,000, you will get a micrometer. Okay, I've developed a mnemonic that I use to remember the order of all of these prefixes, and I hope it's helpful to you. That's mnemonic. That's how you spell that. It's a memory device. Here it is. Just remember that King Henry doesn't usually drink chocolate milk at McDonald's. What does that mean? I don't know. He's health conscious. I intend for it to mean is that K stands for kilo, H stands for hecto, D stands for deca, with a K usually. There is another alternative spelling. U stands for the unit. D again stands for deci or deci. C now stands for centi, as in centimeter. And M stands for milli or milli. And then we have this AT. That's these two spaces here where we skip assigning a prefix. And then we have the micro. So A and T represent the place values that we do not name. Now, if I'm doing a lot of conversions or taking a test, I do not bother with writing all this out. Here's the way I do it. I just tell myself, King Henry doesn't usually drink chocolate milk at McDonald's. Okay? Now, specifically, the symbols that we use for these are kilo, K, hecto, H, deca. For the deca, that means this place value indicates 10 times the size of a unit. We use DA. Then unit, deci, centi, milli. We skip naming, 2 place values, and then we have micro. And we use an MC at McDonald's. Let's say our unit is a meter, which is also represented by an M. So be careful. If you have a single M, it does not mean milli. It means a meter. Okay? So let's go to the left first, just because, I don't know, because. If you have a meter, and if you have 10 of those meters, you now have a decameter. If you have 10 decameters, you actually have a hectometer. And if you have 10 hectometers, you have a kilometer. That also means a kilometer is 1,000 times bigger than a meter. Going the other way, if you have a tenth of a meter, you have a decimeter. If you have a tenth of a decimeter, you have a centimeter. Oh, notice that centa, there's that 100 again. So a centimeter is 1/100th of a meter. Okay, if we continue further, we have a millimeter. I'm not going to name the A and the T, but I am going to write out a micrometer. Okay, it's 1/1,000,000th the size of a meter. It's little. If instead of meters I am using the unit gram, then I will have a kilogram. If I have 1,000 grams, 100 grams will be a hectogram. 10 grams will be a decagram. A tenth of a gram would be a decigram. 1/100th of a gram would be a centigram. 1,000th of a gram would be a milligram. I'm not going to name those. Okay, and 1/1,000,000th of a gram would be a microgram. And the other basic unit of the metric system is the liter. And people often use a capital L here as opposed to all these lowercase letters we're using so that it does not look like a 1. If you have 1,000 liters, you have a kiloliter. If you have 100 liters, you have a hectoliter. If you have 10 liters, you have a decaliter. If you have a tenth of a liter, you have a deciliter. 1/100th of a liter is a centiliter. 1,000th of a liter is a milliliter. Not going to name those two. And 1/1,000,000th of a liter is a microliter.
So let's take a look at this situation. A patient should receive 1.75 milliliter of 0.9% sodium chloride IV every 12 hours. What is that volume in liters? Okay, something I want to point out to you is that the information that I have circled there, although it contains a number, it contains a percentage, it's actually not part of the problem we're working. If you can substitute a word such as solution here, and the problem or the sentence still makes sense and you can still calculate what they're asking for, then go ahead and do that. You don't need to worry about the percentage for this problem. We're going to assume that you already have a solution stored somewhere and that you are not being required to formulate that solution. So let's apply some dimensional analysis to this problem. We're starting with 1.75 milliliters, so I'm going to put that over 1. Now I need a conversion factor. All right, I need to go from milliliters to liters. Therefore, I'm going to remember that there are 1,000 milliliters in 1 liter. So I'm going to wind up canceling those milliliters, and I will have 1.75 liters divided by 1,000. And when I divide by 1,000, I'm going to move the decimal place 3 spaces to the left, and I'll put my 0 in front of that to clearly indicate to everyone that there is a decimal point coming up. Get rid of the position my original decimal was in. And now I have 175 hundred-thousandths of a liter. So we can get our answer via dimensional analysis, but when you are converting within the metric system and you're staying within a length measurement or a mass measurement or a volume measurement, you don't need to refer to dimensional analysis. There's actually a quicker way, which I also want to teach you, as well as dimensional analysis. If you have 1.75 milliliters of this solution and you want to know what the volume is in liters, take a look at the letters left behind from the King Henry sentence. King Henry doesn't usually drink chocolate milk. Here's my milliliter. I'm going to put an L here because our base unit is liters. And what do I have to do to get from milliliters to liters? Well, I have to move to the left 1, 2, 3 times. So I'm going to move this decimal point 1, 2, 3 times. There's my new decimal point. Now I fill in the swoops with zeros. I'm going to put an initial 0 there to alert everyone to the decimal point. And now I can get rid of my extra marks here, get rid of my swoops, and definitely get rid of my original decimal point because I moved it out of there. And once again, I have no longer milliliters because I've converted to liters. So I moved the decimal point 1, 2, 3 to the left, and it became liters. 1.75 milliliters equals 175 hundred thousandths of a liter. So let's just practice some conversions now. We have, for example 1, 3.4 kilograms equals how many grams? All right, so I'm going to write my 3.4 over here, and from my prefix letters up here, I'm going to go from kilograms all the way over to grams because this is my unit. If it helps, you can go ahead and write the base unit, grams, meters, or liters, above the U there. Okay, I need to go 3 places to the right with my decimal point. 1, 2, 3. So I'm going to turn this decimal point into a comma because I now have 3,400 and my unit is grams. For the next example, my unit will be meters, or the meter. All right, I have 10 millimeters, so I'm going to start here at millimeters, and I'm going to move to, now be careful, it's just a D. I'm going to be moving to decimeters. So I'm going to move the decimal place to the left. Therefore, where's my decimal in this 10 millimeters? It's right here. I'm going to move it 2 to the left, 1, 2. That's the new position. That's an initial decimal place, so I'm going to put a 0 in front of it so everybody knows to look for that decimal point. And what is my new unit? Decimeters. Example number 3. I have 0.3 and I have decaliters, DA. Where am I going? I'm going to milliliters. Liter is my base unit. So I need to move 1, 2, 3, 4 to the right. So the decimal point moves 1, 2, 3, 4 into this position. I fill in zeros to fill up those swoops. Now I no longer have an initial decimal, and I no longer need that initial 0. Get rid of the swoops. Well, there's nothing following that decimal point, so we really don't need it either. To make this easier to read, though, I can add a comma here, and my units are milliliters. Always remember to fill in the units. Please remember, if you're using the base unit of grams, you are measuring mass. If you're using the base unit of meters, you are measuring length. And if you're using the base unit of liters, you're measuring volume.
There is another way to measure volume in the metric system. I'd like to show that to you now. Imagine that you have a cube that has a measure of 1 centimeter on each side. So a height, a length, and a width of 1 centimeter. So you have 1 cubic centimeter, or in many of the sciences, you'll write it that way. But in the old medical dramas, you always heard somebody yelling for so many cc's of something stat, okay, and writing cubic centimeter as cc. Because if you write it really quickly, it can look like a U. This is really kind of frowned upon anymore, and instead, because 1 cc equals 1 milliliter, it just makes more sense to use the milliliter version. But you do need to be able to convert between them. So 1 cc equals 1 milliliter. As you know, because I'm sure you read your textbook as instructed, it does a very good job of discussing this and giving you even more examples. So take a look at that. And as always, contact me if you have any questions. Have a good day.